solve some tasks related to collections. So we'll start from array list. We're asked to create an array list of 5 numbers and add one more number to the end and print the entire list. So let's create a new class. Let me call it main. And we create a main method, an entry point in the program. Right, so let's create an array list. To create an array list collection, we can use array list and specify the type of the array, so it will be integer. So array list is basically a collection of ordered elements that are stored sequentially in the memory. So now we'll give it a name. Let's call it list, and we'll call a constructor new, a keyword new that we'll call a constructor array list. And now we're done. To add the element to the array list, we can use the method add. So name of the list, then method add, and in parentheses we can pass the values of the elements that we want to add. So let's add 5 numbers. I'll copy this. Right. Let me say 1, 2, 3, 4, and 5. So we created an array and added array with 5 numbers. And let's add one more number to the end. Let's call it 6. And to print out the whole array, we can use the function println, system out println, and the name of the array. Now let's go and run this. So here you can see the result. Alright, correct. So now let's write a program that removes all even numbers. So to do this, let's create a static method. Remove, let's call it remove even nums. Right. So let's also, we forgot to specify the return type. Let's make it void. And in parameters, we want to pass an array, so we'll write array list. We'll pass our array. And now we can use a built-in method to the collection array list, which is called remove if. So list dot remove if remove if the number in the array when divisible by 2 without a remainder, it will remove that number from our array list. Right, so let's go and call this method. So remove even numbers, and let's pass our list, and again let's print out. So now we can see the difference. This is our first list, and in the second list we can see that the even numbers are gone. So our function works correctly. let's create an array list of strings and find the longest string in it and print. Right, so to do this, we can simply change the type of the collection to a string. The same process, and let's add some strings. Right, list. And to pass the string into an array, we use a semicolon. Right, so let's say apple say orange banana. Right. Let's try to print this. Correct. Now let's find the longest string in the array. Alright, so let's add one more list. Let's make it bigger. Let's say watermelon. And let's create a string, a new variable, longest, that will store our longest string. Now let's implement a for loop. So for each word in list, we want to check if condition. So we can use a method dot length, the word dot length, to get the length of the string. So if the word is greater than the length of the longest string, then we will assign the value of the word to the longest. The value of the variable word to the variable longest. Right, and now we can print out the longest. Let's go and run this. So the result should be watermelon. Right, so we have a list with 4 elements: apple, orange, banana, watermelon. And we can clearly see that watermelon is the greatest one among all the elements in the list. Right, now let's implement a method that merges 2 array lists into one and removes duplicates. Right. So let's create a second list. We call it list 2. And add some elements to that list. Let's take all of these elements and add it to the second list, and add some unique elements as well. Let's add the watermelon. Let's add the lemon. Let's add peach to this list. Right. And so also add page to this list. So we're asked to create a method that will remove the duplicate elements from the list and will merge two lists. So let's create a static method, public static. It will return array list, string, and the name will be merge list. So it has parameters, so we should pass two lists. Again, array list, string list 1, array list, string list 2. Right. Now what we can do Hash set it contains only unique values. So if we add these lists to a hash set, then the hash set will automatically remove all the duplicate elements. So let's first create a hash set collection with a type string, and let's call it unique, and let's say just set new hash set. And to add elements, to add the lists and the elements of the list to a set, we can use a method add all. So set add all and say list 1, and the same thing for list 2. And here in the end we want to return the set, but we should return it as an array. So we'll use this construction, new array list, and here we'll pass the set. Right. So now let's call this method. Let's call the method merge lists, pass list 1 and list 2. And let's assign it to some array list. So here we can see, let me also print out the list 1 and list 2. So list 1, list 2. So we'll see that these lists have duplicates. Here we can see apple, orange, banana, we have peach. And the third list is the one that we merged, right, using the hash set. Hash set is basically a set implementation based on a hash table. And so all the elements in the set are unique. No duplicates are allowed. Even if we add the duplicates, it will be removed automatically. So in the end we can see that all the elements are unique and no elements repeat themselves. Right. The next task is to write a method that takes an array list and returns a new list with the numbers in sorted order without using the sort method. Right. So let me get rid of this and this. Alright, so to do that, let's first create an array list. So array list of integers, and let's call it a list. Say array list integer, and let's add elements to our list. Let's add some numbers. Say sort these numbers. The return type of the element of the method, the static method, will be array list. The type is integer. Let's say sort list, and parameters we pass our list with the type integer, and what we can do is that we can create a tree map collection. We know that the elements in trees are automatically in sorted order, either a tree map or a tree set. Let's create a tree set. And in the end, we'll convert the tree into an array and return an array. So let's say tree, new tree set. Now we created a tree set. We should add the list, right? So tree dot add all. Again, we can use add all method here. Add all from the list, all the elements from the list, and return. Use that keyword new to transform the tree into an array, and return the tree as an array. Right. So now I will print out the list that we have. It's not sorted, and then we will sort it out. We'll sort the numbers in ascending order and print out the new list. So let me create a new array list, new collection, say sorted list. Sorted list the method sort list, and pass our list inside the sort list, and then we'll print out the sorted list. Let's go and run this. Alright, so now let's switch to the task with a linked list. So we should create a linked list and add 5 rows, print all the elements of the list. So linked list is a collection that stores data in, so nodes store the data in linked lists, where the nodes have the link. The data is stored in nodes, and basically each node has a link to the next element, and all the elements in the linked list are connected with the links to each other, so we can traverse the elements of the linked list through the nodes. Right, so to create a linked list we can use we can use the linked list collection, and let's create an integer with the type integer and the name, let's call it linked list. Let's create use a keyword new to call the constructor linked list. Now we created a linked list, And let's add some random 5 rows. Remember that to add elements to the collection, generally we use the method add, which is built into the collection. So linked list add, let's say 1, 2, 3, and 4. So basically, linked list will it will print out the same thing, like with the array list. We can see that. I can demonstrate. So you can see that looks like the same, but whenever we want to frequently add and remove elements from the collection, it's better to use a linked list because the average time complexity for adding and removing elements in the linked list is constant compared to the array list, where adding and removing elements, the average time complexity for adding and removing elements in the array list is big O n. In the worst case scenario, big O n. So the advantage of linked list is that we can quickly add and remove elements, but the search is slow in linked lists. In worst case scenario, it may take big O of n because we cannot access the elements by the indices in the linked list. To access the element in the middle, we should traverse all the elements starting from the beginning, and it may take the average time complexity is big O of n. Right, so we created, let's say 5. We're asked to create 5 elements, so let's say 5, and we printed the elements, right? So the next task is to implement a task queue with linked list, add 3 tasks to and process them in the order they are received. So as we know, we can also use linked lists to implement a queue. So we can change the linked list to a queue. Basically it's the same thing, but for visuals we can write it as a queue. And now to add to a queue, we can use the method offer to add the element to the queue. So let's say say 1, 2, 3, 4. So we're asked to add 3 tasks. Right, okay, let's keep it 3 tasks. And now let's try to print our queue. So the queue basically works according. Basically, queue is a data structure that works according to principle first in, first out. So in this case, the first element was 1. So that element will be the one that we will process first. We'll process first. So now I will show how this works. Let's write Q, and in order to process the elements in the order they were received, we can use the method poll. So what poll will do is that it will return and remove, it will remove the first element from the head, and it will return it. If we try to print this, we can see that it will return 1. So it will return 1. And if we print out the Q, we can see that the 1 will be removed from the Q, and 2 with 3 are left, right? Let's process one more time. Q.poll. We'll have 3. Right. So correct. Now let's use list iterator to iterate over the linked list in both directions. Let me get rid of this. So let's create a linked list again. Linked list. Say string. Let's keep it simple. Let's say integer. And let's go linked list. New linked list. Let's add elements to the linked list using the method add. Say 1, 2, 3, 4, 5. Right. So now let's implement the list iterator. So list iterator. The type of the list iterator will be string, because it will be integer actually, because we will traverse the integer elements. And let's call it list iterator. Here we should take the name of our linked list and then use dot list iterator to be able to use the list iterator. Now let's print out some message. Forward traversal. So we will traverse the elements. First we'll traverse the elements in the forward direction, and then we'll traverse the elements in the backward direction. So in order to traverse the elements of the linked list in forward direction, we can use the methods hasNext and hasPrevious. So let me demonstrate. So while linked list dot has this actually should be a list iterator, because we're using the iterator. So while list iterator has next, be in an infinite loop and print out the elements using the next method. Right. So to traverse the linked list in the backward direction, we can use, let's say, backward traversal. We can use the same principle. So while list iterator has previous, we'll print out all the previous elements. Right. Now let's go and run this. Just a second. Let's make it more clear like this, so that we could see the elements on the same line. Now let's see. Right, so one more thing. Now we can see that the forward traversal, right? So we start from 1, go to 5. In the backward traversal, we start from 5, then go up to 1. So everything works correctly. Everything works correctly because a linked list is a collection that where the data is represented using nodes that store the data itself and has the links to the next element. So linked list is basically it could be used it could be used as a double linked list as well. So that's what we did here. We traversed the elements in both directions. So now let's solve the next task. Write a method that removes every second element from a linked list. Right, so let's create a linked list. Linked list integer. Let's call it a list. And let's call the constructor and add the elements to our list. So list add, say 1, 2, 3, 4, 5. So we should write a method that removes every second element from a linked list. Right, let's add one more. 6. So let's write a method public static let me use this placeholder t and the name of the method will be remove every second say remove every second none. And let's pass a linked list with the placeholder t. So what this placeholder does is that it allows us to specify the collections without directly writing the type of the collection. So instead of writing the string everywhere or integer everywhere, we can just specify t, and it will dynamically adjust the type of the collection. So we passed our list in the parameters, and now we need to implement a linked iterator. A list iterator, sorry. And say integer. Again, we can put the placeholder. List iterator. Let's call it iterator. And use this construction to be able to use the iterator. Why do I use iterator? Because if I were to directly use a for loop, then I wouldn't be able to safely traverse all the elements of the list, because linked list dynamically shrinks and extends the size of the list. So it's much safer to use the iterator in this case. That's what I'm going to do. The iterator has a method has next, and will increase I by 1 in each iteration. And also we should use the next method that will allow us to move to the next element. And let me put a condition here. So we want every second element, meaning that we want so if I is divisible by 2 with a remainder 1, then it means that it's a second element, right? So we start from 0. 0 is first element, so if we divide it by 2, there will be remainder. There will be no remainder. So if we divide 1, so the next element, so the second element that we need, so 1, if we divide it by 2, the remainder will be 1. So we want to remove every second element. We can use the iterator dot remove to safely remove the element from the list, right? And after we're done, we can print all the elements using the method for each. So list dot for each, and here we can print out all the elements using the function for each, right? Now let's call the method remove every second element, every second number, and pass our list. And so in this case, this should be removed, this number, and also 6.
should be removed. And we have 1, 3, 5. So correct. The next task is to implement a method that finds and removes all duplicates in a linked list. So let me create some duplicates here, like this, like this. So we have multiple 2s, 3s, 4s, right? Alright, so let's create a method. Public static we use the capital T as a placeholder type parameter that refers to generics. Now the name remove duplicate, and again we have a parameter linked list will be capital T, and let's say list. So now here's the plan. We can create a set, right? So let me create a hash set new hash set, right? So we know that set contains only unique values, so we cannot add duplicate elements to the set. And let me also create an iterator. So list iterator. Let's call it iterator. And list iterator, right? Right. So now let's use a while loop. While iterator dot has next. Let's write and let me create a variable with type T, let's say, to keep track of the current element. Again we use iterator and next, right? So now we'll have conditions. So if the list dot actually iterator, no, and let's actually remove the set into a scene for more convenience. So it will be convenient to track the elements that are already seen and remove them from our linked list, right? So scene dot, we can use the method contains to check the current element, right? If scene contains current, then we'll go into a list and we will remove that element from the list. Else we will add it to the list. So else we will add the element. So else we'll add it to the set. We'll add the current element to the set. Right, so now we can call can also print out the whole set in the end. So iterator dot for each for not iterator, sorry, list for each, and we can use this method to print out every line, every method of the list. Right, so let's call the method. So the logic behind this method is that we'll pass the linked list, right? So we will pass this linked list to this method. This method will accept the linked list, and within the method we created a hash set that will keep track of the element that are already seen. So also we created an iterator to help us to traverse the elements of the linked list, and within a while loop we have this variable current that allows us to keep track of the current element of the set with the help of the iterator and the method next. And we assigned it to with the data type t, which allows us to maintain the flexibility of the program, and it will dynamically assign the return type, the data type of the variable automatically, depending on if it's an integer or string. So these t's, they help us to avoid the mistakes in the program, right? So for type safety. And then we have these conditions. So if the set seen, our set seen already contains the current element from the linked list, then we'll remove that element with the help of the iterator and method remove. Else we'll be adding the elements. Else it means that element is unique. And in the end we'll print out all the elements to make sure that our method works correctly. So let's go and run this. Before that, let me write the method remove duplicates and pass our list with some duplicates here. You can see I'll print out it in the beginning. I'll print out our list and turn this to a print line, and let's go and run this. So here we can see this was the list before and this is after. So before we had the duplicates, like multiple 2s, 3s, 4, but in the end we obtained a unique list. So everything works correctly. Now let me get rid of this. And we move to the next task. Right, now let's see the tasks for the hash set. So we're asked to create a hash set with 5 numbers. Let's go and do this. So we remember the implementation: hash set, then the type, let's say integer. Let's call it hash set. new constructor hash set. Right. Now let's add elements to the hash set. So hash set dot, again we can use add. Let's say 1. I will just copy this. 3, 4, 5. And let's print our hash set. Now the next task is to add 10 random numbers to a hash set and check if it contains the given number. Alright. So let's see. We have the method contains, right? That returns an iterator over the elements in the set. The elements are returned in no particular order unless, right. So this is what we need. We need the method contains. So basically hash set is a set implementation based on a hash table. Hash sets they do not preserve the order in which the elements are added. So let's create 10 random numbers. Let's say 10, 14, 18, 201. So we have 4. Let's create one more. 55. Right. Now let's see. Let's use the method contains. So we're asked to check if it contains the given number. Let's check if our hash set contains 3. So we can see that it's true. So our method returned true for this particular example. But if we really want to add random numbers, we can actually create a random, use a random class. Let's say random, use the constructor random. Now let's use a while loop, and while the size of the hash set is less than 10, we will keep adding random numbers to our hash set. So hash set dot add first we should use random dot next integer and hash set dot add random. I forgot to assign the random values to some variable. Let's call it integer number. And let's say the range of our random numbers will be from 1 to 100, and we should pass the number. Right. And then we can print out our hash set. So hash set, and also print out and see. Let's see if our set has the element 3. So if it contains the element 3, let's go and run this. So as you can see, we don't have 3. We don't have 3 in our set, so it returned false. Let's try one more time. Say 30. Let's see if we're lucky. Again, false. Alright. Now let's move to the next task. Implement a method that takes a list and returns a set without duplicates. Alright. So let's write a method, public static, let's use the placeholder t for convenience, void let's call it return set. And actually let's not use it this time, because I will be specifying the type. So we'll accept the list and return a set. So we will accept a list. Actually, let's keep the type placeholder. It's more convenient. Let's call it list. So what this does is that it will just return a set instead of a list. So the return type should be set, and let's return new hash set and pass our list to the hash set. And let's actually change it to string, because we were asked to make it a string. So string. Right, so now we should create let's create a list and check our program. So let me get rid of this. So we have list string. Let's call it list new list. Oops. Right, so now let's add some values to our list. So list add, let's say, let's use fruits, apple, banana, again banana, watermelon, let's say strawberry. Right. So we have some duplicates here. Let's add in more duplicates. And let's actually print it, the list, and then call the method return set list. And create a set for our method. So set string let's call it unique set and print out our unique set. Right, so let's see. Here we have a long list with duplicate elements, but after we used our method return set, it removed all the duplicates and only unique values are left in the set. Correct. This is occurred because set is a collection that does not allow duplicates. So it checks using the methods equals and hash code to be able to distinguish between the duplicate elements, and if it's a duplicate, then it will not add that element. It will simply not add that element to the set. So right, the next task is to write a method that checks whether a hash set contains all the elements from another set. Let's go and do this. Let me create a set. So I will comment this. We can actually remove all of this. So let's create a set of integers, of course. Let's call it just set or hash set, new hash set. Let's copy it and let's say hash set 2. Now let's add some elements to our hash set. Dot add, say 1, 2, 3, 4. Let's copy all of this and add it to our second hash set. And now, in order to check if one set contains all the elements from another set, we can use the method contains all. So what we should do is write the name of our set, then use the method contains all, and here we specify the second set. And this will return some boolean value, so let's assign it to some boolean. Let's say result, and I will print out the result. So it should either be true or false. So in this case, our sets, they are identical, So the result is obvious, it should be true. You can see, true. Let's try to add some duplicates. The result should also be true, because there are no duplicates allowed in the set. But if we try to remove, so now they're not equal, so they're different now, it should be false. Actually, it's not false because the set that we're comparing to, so in this case we're comparing a hash set 2 to hash set 1. So hash set 1 contains all these elements that hash set 2 has. So if we were to change the order, so if we were to compare the hash set 2 to the hash set 1, then it will be false. So as you can see, right, so the order matters. Now let's move to the next task. Implement a cache from a hash set that automatically removes old entries after a certain interval. Let's go and do this. Alright, so let's create, we already have a set, so let me just remove this, and let's say a set cache. Let it be string, and let's add some elements to our cache. So add, let's say something, some action 1, action 2, some general action, okay, action 3. And let's print out this before we clear the cache. So before clearing, our cache and to clear the set from all the elements, we can use the method clear that will remove all the elements from the set, and now we can print out the cache. Actually, let me make it look nicer. So this is after clearing. Let's try and run this. So as we can see, before clearing we had, and notice that the elements are in they're not in ordered position, like they're added randomly, so the set does not preserve the order of the elements in which they were added. Right. So the next task is to create a linked hash set and add 5 rows to it and check the order of the elements when outputting. So linked hash set is basically a collection that stores unique elements. So basically it's a set implementation based on a hash table and list, and this collection, it preserves the order of the elements. So let's see that in action. I'll create a linked hash set of the type are we asked. So let's keep it simple. Let's say integer. It's called linked hash set, and use the keyword new to call the constructor linked hash set. So now we created a linked hash set. To add the elements, again we can use the same method add. Let's say 1, 2, 3, 4, 5. 5 rows, right? So, and now let's try to print out the result of our linked hash set. Let's see what's inside the linked hash set. So as we can see, the order of the elements is preserved, so we added them in this order, and in that order the elements are stored. Right, let's try to change this order. So we can see that the order of the elements in the set are in the order they were added to the system. So everything works correctly. Now let's write a method that adds an element but does not add duplicates. Alright, so let's get rid of this, and let's keep the name of our set simple. Let's call it set, and now let's implement a method that will add elements to our set. So public, of course it will be static, so that we would be able to use the method without creating an instance of the class main. The return type will be boolean, and let's call it the name of the method add element. So we should pass our linked hash sets. The type of our set will be integer, so let's call it a set, and some number. So integer number. Right, and we'll return set dot add and the number that we pass. Right. Now let's try to add some numbers to our set using the method add element. So we call add dot element, and first we pass our set, then we pass the element, the value that we want to add. Now let's try 20, 30, and let's keep 30, so we could see that the result. Also, we should wrap it around our print method. Let me copy this. So 20, 30, and 30. Now these methods return some value true or false. So if the element is duplicate that we're trying to add to the set, then they return value. The console will print out false. Otherwise, it should print true. So let's go and run this and see what we get. So as we can see, first three values are true because they are unique, and the last one 30 is a duplicate value, so our method returned false since a set cannot contain duplicate values, and this is the result of our set. Now let's implement a cache of the last 5 unique pages visited by the user. Alright, let me get rid of this and this. Alright, so let's change the name of the set to cache. Sorry, I was mispronouncing this. It's actually cache. It's pronounced as cache. So we have cache here, and now let's write a method that will allow us to track, allow us to visit the pages. So public static void visit page, and we'll pass here our linked hash set with the type string and call it cache, and the URL, so page URL. Now we write a condition, so if the cache contains our URL, then we will remove it from our cache. So cache dot remove URL. Right. So now let's add some URLs. So cache dot add page.com. Let's say page1.com. Actually, we should have used the method. So let's use the method visit page, and here, so first we pass our cache and then we pass the string. So page1.com, let's say. A type mismatch here. That was correct. Let me copy this and add some new pages. Page 4, and let's keep the page 4 twice, so it's not unique in this case, and let's say page 6. So there should be no page 4 in our list. made in our cache. So let's try to run this. Right. We actually want to have the last 5 pages. So in order to do this, let's first implement a final variable of the type integer. Let's call it max size, which is equal to 5. So 5 unique pages. And here we should also be able to add the elements to our cache. So let's say cache add the URL, and let's also pass our max size. So integer max size we will pass the max size. Page 5, page 5, page 6. Alright, now we need another condition here. So if the size of our cache is greater than the max size, then we can use an iterator here let's implement the oldest page and so we write cache dot iterator to be able to traverse the elements of the cache, and next to help us traverse the elements of the cache one by one. And we want to remove that element from our cache, so cache dot remove oldest page. So what this will do is that whenever the size of our cache exceeds the maximum size, which is 5, so whenever it exceeds the size, then it goes and removes the very first page that it visited. So this allows us to keep the track of the last 5 unique pages. So now let's try to test our method. So we can see that page 1 is unique, page 2 unique, page 3 is unique, page 4 is unique, and page 5 is not unique, so it will be removed, and page 6 is also not unique. Now let me add another page, and I'll call it page 7. Let's see what we got. So as we can see, so let's run it one more time.
actually, so we can see that we have the page 3, 4, 5, and 6 and 7. So this means that it kept last 5 pages and returned the unique value, so it didn't return the same page twice, and it only returned the last 5 unique pages, same as we were asked the task. Now let's write a method that finds the intersection of 2 linked hash sets. So let me get rid of this and this. Let me call this set 1. And let's create one more and call it set 2. And I will actually change it to integer. And let's add some elements, some numbers to our set. So set1 dot add 1, add 2, 3, and let's add 4. Now let's add some elements to our second set. So set2 add 1, 2, let's actually start from 2 and go to 3, so we could have some intersection here. 2, 3, 4, and 5. So the intersection between these sets is 2, 3, and 4, because they both have these elements in this set. Right. So in order to find the intersection between 2 hash sets, let's write a static method, public static, that will return a set. So it will also be a linked hash set. The return type is linked hash set of integers. And let's call it intersection. Intersection of sets. Intersection of 2 sets, let's say. 2 sets. Now, as a parameter, we pass 2 linked hash sets. So linked hash set of integer set 1 and linked hash set of integer set 2. Right. So now what we want to do is we want to use a method contains to find out that the both sets contains the same element, and if they do, we will add it to a unique set. So let's create a new set, integer. Let's call it intersection. Interset. New linked hash set. And we can put our first set within, the first set into the set. Now we can use the method retain all. So interset dot retain all from the set2. So what this does is that it allows us to take all the elements that are shared by both. It will leave only those elements that exist in both sets. So meaning it will find an intersection between these two sets. And at the output we return the interset. Alright, now let's first print out our first set, then second set, and then call the method intersection and print out that set. So first let's create another linked hash set of type integer and give it a name interset, and here we'll call the method intersection and pass our two sets, and in the end we'll print out the intercept. Let's see. So we have two sets, set 1, set 2, and we see that the intersection is 2, 3, 4, and that's what we got after calling the method intersection of two sets. Correct. Now let's implement a mechanism for storing unique actions on a site based on linked hash set. Okay. Let me get rid of this. And this. So first let's create a linked hash set of the type string. And let's call it actions. Unique, okay, let's call it actions. Use the keyword new to call a constructor linked hash set. Now we create a collection linked hash set. Now let's create some actions. So actions dot add so what action can it be on the website? Let's say pressed button, press some random button, and let's duplicate. Let's be a little bit creative. Let's say user entered in a website. Then let's say user clicked button let's say user visited the page about us. Let's say, let's copy this action and create another one. And say user clicked the button buy. And let's add another one. User left the page or the website. All right. As we know, linked hash set basically is a set implementation, so any sets, they do not contain the duplicate values. So any duplicate values will be excluded from the set. Basically, those elements will not be added to this set. And also, a linked hash sets, they preserve the order in which the elements were added. So let's see the result. To see the result, we can use the for each operator that will allow us to go through every element. Right. Yes, we don't actually need this. Either we can use this method or let's actually run this and I'll show another method. So we can see user entered the website, user visited a page about us, and user clicked the button buy, and this action was not saved to the set because it's a duplicate that is checked with the help of the method equals and hash code. So, and here is another method how we can traverse the elements of our set. We can use a for loop and here specify the iterator action, and we can use our set. So for each action in actions, we can say we will go and print out every action of our hash set. Let's go and run this so we can see everything works correctly. Right.
Alright, let me remove all of this. And let's go to the next tasks. So let's create a tree set of 5 numbers and print it. So tree set is basically a collection where basically tree set is implementation of set based on a tree, and all the elements in the tree set are in sorted order. So now we can see, after this example, we will see that even if we enter the elements in the order that is not sorted, the tree set will automatically sort them. Right, so import. So let's say tree, use the keyword new, tree set. And remember to add elements to our tree set, or to our tree, we can use the method add. And let's say 5, some random numbers, 2, 1, 4, and 3. Note the order in which I created these elements, so they're not in sorted order. But if we were to print out our tree, you can see that the elements are in sorted order. Right, so this is our result. Now the next task is there to write a method that adds numbers to a tree set, but does not allow duplicates to be added. Alright. So let's get rid of this and write a static method. So public static does not return anything, and let's say add unique elements. Let's just say add elements, right? So here we will pass our tree set. Tree set with the type integer and with the name tree and some number, some integer number, let's say number, that we want to put inside our tree. And here we'll have a condition. So if tree contains, so if tree already has the element, meaning the number, then we can just exit the loop. Or we just exit. If not, then we'll add the element. So if not, we will take our tree and add the number. Right. So now let's try to test our method and call the method add elements. Pass our tree, and let's say 1, let's say 2, 5, let's keep 5, and let's say 2 again, and 3. So now we should have all the unique elements. So this should not be added because it's a duplicate element, and this too also will not be added. Let's go and check this. So we can see not only that the elements are in sorted order, but also they are unique. Why? Because we used the method. The method here, it works correctly. Now let's find the nearest greater and lesser numbers to a given number in tree set. Alright, let me get rid of this and this. So let's add some elements to our tree. So add tree.add again. let's take some bigger numbers. 10, 20, 30, 40, and 50. And let's say, right, so also we have our potential target, or let's say some number. I will use big integer here as a return type, so wrapper integer. I will explain it later. So let's say 35, and as we know, tree has a collection tree set has the methods like higher and lower that returns exactly one element greater than the specified element, so I mean the number. So let's call that method tree lower. So we pass our number here, and also it should be of wrapper type integer. Let's call it greater. Should be actually lower. And also we have a greater one. Here we use higher instead of lower. So why do we use integer instead of just int? Is that because integer can handle null values. So in case there's no element, for example we pick 50 and there's no element higher than this in the specified tree, then it will return null, and if we use int we'll have to handle the exception. But integer can have null values, so it's more convenient to use integer. And not only that, but also the return type of the method higher and lower is wrapper integer. It's not int. It's not a primitive data type int. It's a wrapper integer. So now let's try to print out our lower and higher lower and greater variables and see the results. So lower and greater. Let's go and run this. So we passed 35. The numbers between 35 is 30 and 40. So it's correct. But if we were to say that our number would be 50, let's say, then it will return null for the greater, as you can see. We could handle this now using a ternary conditional operator. So in order to do this, let's start from lower. We'll take parentheses, and then here comes the condition. So if lower does not equal to null, then we'll print out lower, else we'll print out none, and close the parentheses. Now again we'll open parentheses here. If greater does not equal to null, then we will print out greater, else we'll print out none. Now let's try and run this. Let's try to run this. So we get none, as you can see, instead of null. And if we were to give 70, then we would get null in both cases. Not exactly, because we have 50, which is closest lower element to 70. But if we were to say 0, of course you know the result. It will be none and 10. Alright, now let's move to the next task. So implement sorting users by name with tree set and comparator. Alright, let's get rid of this. Alright, so let's rename our tree to users, and let's implement a comparator. So comparator, and it should be string, and the tree also should be string. So I'll call it just comparator, and here we can use the method of comparator, which is natural order. And now let's add some names to our tree users. So add, say, Alice, John, Bob, Wayne, and in the end, let's print out our tree with users. And to be able to use the comparator, we should specify it within the parentheses, the name of the comparator that we created. Now the elements in the tree users in the tree set will be sorted in ascending order with the help of the method natural order. So let's print out the result, and we can see that the names are in ascending order. Alright, let's switch to the next task and remove all of this. So the next task is to use tree set to store unique words from text in sorted order. Right. So in the previous example, even if we were to not implement the comparator, it would anyway store the elements in the sorted order because of the property of tree set. Tree stores the elements in ascending order. So now let's use some duplicate values. Let's print Alice twice, Bob twice, John, and let's see the result. So we can see that regardless of how many times we write the same element at the end of the at the output it anyway stores the unique elements because it's a set, and the elements are in sorted order because it's a tree. Alright, so now let's get to the task. Let me remove all of this. Let's call this set words, since we'll be storing words. And let's create a text, string text. So I have some lorem ipsum here. And now we can use a for loop for each word. So for each string word in words, actually not words, but we want to get each word from the text, so I'll use text dot split, and here we can use this notation that will allow us to split our text by non-word characters, so something like spaces, commas, dots, and we want to add those words to our tree. So use words dot add word, and we can also convert the word to lowercase for convenience. Right, and in the end we'll print out our tree set. So use system out, print line, words. Alright, let's go and run this. So these are the unique words. And they are in ascending order. So you can see that there, in this text there are words that are repeated. Right. So we got the unique set of words. Alright. Now we're moving to hash maps. Let me delete all of this. So we have a first task is to create a hash map with a return type string, comma integer, and add 5 pairs of name, age, and print all entities. So as we know, hash map is a collection that stores data in a key value pairs. So we can add some keys which will be converted to a hash code with the help of the hash function that will allow us to quickly access the elements from our hash set. So basically, in simple words, hash set is a hash map. Hash map is a dictionary implementation based on the hash table. So hash maps allow us to quickly access the elements with the help of the hashes or keys, right? So now let's add some 5 elements with a key value of string and value of the key will be integer. Let's call it users and use the keyword new to create a new hash map. Now, in order to be able to add elements to a hash map, we can use a method put. First we pass the key, so name will be the key, say Adam 1, let's say. So the important thing is that in hash maps we can have duplicate elements, but the keys must be unique. So we cannot create Adam or whatever twice with the key 2 because it already exists. We try to do that, we'll get an error. Most likely, no? We didn't get error, okay. Alright, let me remove this. And let's add some more elements. Say John. And let's change this to Sarah. Let's change it to Rick 4 and one more Nero. Right, now let's print out the values of our hash map. So the name of our map is users. So let's see. Now we should get a key value pairs. So this is it. Adam, Sarah, and yes. So the order of keys is not sorted in the hash map, but it is sorted in the linked hash map, which we will see in the next and the following tasks. So for now we have a hash map that does not preserve the order of the elements, the order of the keys to be more precise, and is used to store the key value pairs. Alright, so we created a hash map with a name age and printed all the entries. Now let's check if a given name exists in a hash map. So we can easily do that with the help of the method, which is called contains either value or key. So in this case we want to check if the name exists, so we use contains key, because our key is a string. And let's check if we have Daryl in our hash map. So this should return either true or false, so we can print that out using a system out print line function. And let's do one more for another name, say Alice, which we don't have, so we should have true and false. As you can see, true and false. Alright, now let's implement a method that removes all users under 18 from the map. So this actually should have been an age. I just put some random numbers. Let me change this. 15. And let's print that out to see it one more time. Let's remove this and run again. So we can see the name and age, name age of the users. Alright, now we're asked to remove all the elements that removes all users under 18. So let's go and do this. Our method will be static, so public static of the return type void. So remove under 18, and in parameters we pass our hash map. And specify the return types string and integer, and the name of our hash map will be users. And here let's use a for each construction. So users dot for each here we'll specify the name and age, and it should be in parentheses actually for us to be able to use this. And oops, we will have an if condition here. So if the age is under 18, we'll take that user and remove it. So we'll take the user and remove. And remove the elements. Remove either name, or we could also say age. Let's keep the name. There's no difference. So if the age is under 18, we will remove that user. Alright. Now, so how many users do we have under age 18? Let's add some more. Let's keep Sarah 10. Let's make John 17. There's only Rick. Let's keep Daryl 19. So we'll print users before and after. So here we call the method remove under 18. Pass our users. Then again we'll print out the same hash map. We have an error. What does it say? I think I should change it to, let me use a different method for this. So let's use iterator, right? So iterator and map.entry that will allow us to access the key value pairs of our hash map, and the types of our entries is string and integer. Let's call it iterator, and here we'll write the name of our set, users, and we can use a special method, entry set, that will return all the key value sets of our hash map, and then we can use the iterator. Alright, so now let's write a while loop. Let me use a while loop to traverse all the elements of our hash map. So while the hash map users has next, while the iterator has next, because has next method is related to iterator. It's a method of iterator. While iterator has next, we'll have a condition here. If iterator next, so meaning the element from our hash map will be checked one by one with the help of the iterator.next method that will check every element, and if it's less than 18, then we'll remove that element from our hash map. So iterator.remove. Alright, so also there we should specify the method getValue. So because these integers, they are values, if it was the key, then we could use the getKey instead of getValue, but in this case we use getValue. Alright, so now we can go and run our program. Now it should work correctly without any errors. So as we can see, we had Adam, which is 18, which will stay. So Sarah is underage and John is underage. So these two were removed from our hash map. As we can see, our program works correctly thanks to the iterator and its method. Its methods as next and next. Alright, now let's move to the next task. So we have to create a hash map where the key is a word and the value is the number of its occurrences in the text. Alright, now let's go and implement this. First, let's delete all of this. So the number of occurrences is an integer and the text is a string. Right, so let me create some random text here. So string text, I will say apple, apple, what else? Let's say orange, watermelon, watermelon, and one more time watermelon. So let's assume that we want to check. Let me copy this one more time. I'll paste this here. So comma, and like this. So let's say I want to find how many times we have apple, orange, and watermelon in this specific text. Well, we can use our hash map for this job. So let's add key value pairs to our hash map. Let's rename this not users. Let's just call it a word count. Now let's add the key value pairs. So word count dot put. So actually no. Actually we should use a for loop. So for each string word in our text, that will be splitted by the comma let me actually use double quotations. For each word in our text, we want to have this condition. First of all, we'll convert the word to a lowercase to make it not case sensitive. It's a good practice, even though all the words are in lowercase in our text. And then we can use this method, word count put the word, and there is a method that is called get word default, which we can use. So get or default, that will allow us to avoid writing the while loops, and it will check if the word exists in our hash map. Then it will increment the value by 1. Otherwise, it will create a new element and increment its value by 1. Right, so after the loop we can print out the result that we get. So the result is our hash map word count. Now let's try to run and see the result. So apple, there are 2 occurrences of the apple, 6 occurrences of watermelon, 2 occurrences of orange, and 2 occurrences of apple. So it took our apple as a Alright, let me see. Probably it was because there is no space between the apple and the comma, and the compiler thought that it's a different element. To avoid this, we can use this notation instead of just comma. which will allow us to avoid all non-word characters. So it will allow us to avoid all non-word characters. Basically, allow us to avoid all the symbols, right? So let's go and run this again. Now we can see that the elements are unique. So orange, apple, and watermelon. Now everything works correctly. Everything works correctly thanks to the method getOrDefault, which is provided by the hash map, which accepts the key and default value. So in this case, key was the word from our text, and the value was the number of occurrences of that word in the text. And we used to add 1 every time we put a word, depending if the word was encountered before or not. Right, so let's move to the next task. Let me clear all of this. Alright, so let's create a hash map. I mean, we already have one. Just let's change the name to cache and replace it to string. Okay. Now we can use the method add to add some data. I mean put, because we're using a hash map. So cache.put. Now we pass the key and value. So let's say key 1 and some value. Let's say value. Alright, now we want to be able to clear the cache after some period of time. So first let's print out the cache. So this is B4. Now we can use a special method from the class thread.sleep, and pass the time in milliseconds. So 1 second is 1,000 milliseconds. So let's make it 2,500 milliseconds. So what this will do is that it will allow a thread to stop the execution of all the programs, and it will just wait 2.5 seconds, right? And after that we want to clear our cache. So let's say cache, we know the method clear that deletes all elements from the collection, and then we'll print out our cache again. So this is after. Alright, and also one moment, in order for us to be able to use the method sleep, we should write an exception line. So we should write interrupted exception to avoid the mistakes in the program. So now let's go and run this. So we can see key value, and then after some time it returned an empty hash map. We can also make it like get value, get, oops, so we use get to get the value and pass the key. So let's say, so we can pass our key, so get key, and let me do the same for the second output. So what this will do is that it will look up in our hash map for the key in this case. So yes, it will look for the key, and if there is a key, then it means there is a value, so it will return the value. And after this method will be run, so after this method runs and 2.5 seconds passes, it clears the cache, and then there's no key in the cache, and it will return null. So let's go and see. So value, and after some time you can see null. Yes, everything works correctly. Now let's go to the next task. Now we go to linked hash map. So basically the difference between linked hash map and hash map is that the elements in hash map are they do not preserve the order. So the order of the elements in which they're stored in the hash map is random, but in linked hash map the order is preserved. So the order of the elements is arranged in the order we add them to the linked hash map. So we can see on this example, so we're asked to create a linked hash map and add 5 elements to it, and then print them in order they were added. Alright, so let me get rid of this and I will create a linked hash map, not hash set, and also I will remove the exception, and this is linked hash map. And the arguments will be let's say integer for the key, and for the value we'll have string, and the name, let's call it linked hash map, and call the constructor to create a collection. Now again we can use the method put to add the elements to a linked hash map. So we will use the name of the linked hash map, and then use the method put, and we will pass the key and value value, let's say value 1, and let me copy this, value 2, key 2, value 3, key 3, value 3, value 4, key 4, key 5, and value 5. So now we can print out the result, linked hash map. So we can see that we added them in this order, so in sorted order. We added them in sorted order and they're stored in sorted order. But if I were to change this, then we can see that a 5 changed its position because it was added before 4, and 4 comes after 5. So this is the meaning of this is the meaning of when we say the order of the elements is preserved. So the order of the elements are stored in the order they were added to the linked hash map. Right. Now let's go to the next task. and we're asked to implement a phone book with linked hash map, add, find, and delete contact. Alright, so let me get rid of this. So phone book, a phone book with linked hash map. So we should have also string, let's say. And let's call it a phone book. Now let me create some static methods. So public static void, let's say add contact, and we'll pass our linked hash map with the return with the parameters with the type string for the key and value, and the name we'll call it phone book. So add contact. To add contact, we can use the method put that's built into all the maps. So we say phone book dot put phone book put we also should pass keys and values. So it's a string key and string value. Sorry, value. Actually, for convenience, let me keep the number of the integer to make our lives easier. And first, actually the other way around, sorry, the other way around. But we usually store the names and the value is usually the number, so that was actually correct. So integer and the value is integer. So we put as a key, we pass the key, and value we give the value. Alright, now let me copy this, and I will add another method. I will add another method find, and let's keep this simple, just add. So find, and here we will just change it to get, right? And here we should pass the key only. We should pass the key. Alright. Also, we can use overloading in this case. We can copy this, and instead of key, we can find it using the value. And here we don't need the value, we only accept the key, and in this case we don't need a key. Alright, and one more thing to delete the contact, so I will copy it again. I'll copy this and delete. So to delete, we use the method remove. So remove key value. We could also remove it using just key or just value, but I will keep it key value. So, or I could implement another overloading here and just remove the value, and it will work just fine. So now let's create we should use the methods. So let's add some contacts to our phone book using the method add. So add, first comes the name, so let's say Alice, and her phone will be 1234. And we forgot to give our linked hash map. So it's a phone book. Right, let's add some more. Let's say, of course, John. And he is number 4567. And one more, let's say Rick. And his phone will be 0147. Okay. Now we can print out our phone book. So system out print line phone book. Of course, we could also iterate over all the elements and print the keys and values separately, but let's just see what we get in this case. It will print out as a dictionary. Alright, so we have some contacts. Now let's check delete function. Or first let's use find function. So find, so we have two find functions. You remember, either we can use a value or a key. So let's say find from our phone book Alice. Right, so find Alice. And of course, there is a mistake in our method, so we will see it now. Because our method does not return any value. Yes, you can see it here also. So find should return some values. So find should return it should return returns a value is of type integer. It should return this. You can write it like this, and we should specify the return type, so it's not void in this case. Value is of type integer, so it will be integer. Right, so here so with the remove functions it's okay, but here key is string, and we want to be able to return that. So return phonebook get key. Alright. Oh, we mixed up things. So key is a string, so when we pass it, the name should get the number, so not string, it should be integer. And in this case it should be string, because we passed the value. But okay, let me get rid of this. And now we find Alice, so we find the number of Alice. Alright, it will return the number of Alice. It should be 1, 2, 3, 4. Correct. And now let's say we want to delete Alice. So delete here, so we can pass just key. So we'll pass just key. We don't need this. Let's not overcomplicate our lives. So we want to delete Alice. Alright. Should pass the phone book. Phone book, Alice, and of course then we'll print out our phone book. So let's go and see how this works in action. So we had Alice, then we found Alice's phone and deleted Alice. So you can see it here. Alright. And here you can see Rick has a different number, probably because of the 0 in the beginning. So if we try to do this, let's see what we get. Now everything works correctly. Alright. So we tested our functions, our methods, add, find and delete. Everything works correctly. And now we can move on. So now we're asked to create a linked hash map that stores the user's browsing history, maximum 10 elements. Let me get rid of this and this methods. Alright, so let's change the integer into a string so that we could store the URL and the title of the website. Right. Okay, so to add the elements to our hash map, linked hash map to be more precise, we can use again the method put. So put, so the key in this case is URL, it will be URL, right? So let's say some google.com, title Google, let me quickly add them. Now I added the pages and the titles. So now we can print all the elements using a for each loop. So history dot for each. Here we can use this notation, system out double colon print line, print line, to print out all the elements of the our linked hash map. Let me actually use the more precise notation. So we want URL and the title. We can use this kind of arrow to be able to perform the print operation. So URL plus, let's say, some space, title. Alright, so now let's go and print this. So here we get the URL and the title of the website. Alright, so the next task is to write a method that will sort a linked hash map by values. So let me get rid of this. Actually, let's keep the websites. So we'll try to sort by the titles. Let's write a method, public static void sort. Alright, so here we will pass our linked hash map with string and string, with the types string and string, and we'll call it map. Alright, so in order to sort the our map by the titles, we can use collections.sort with the comparator. So in order to do this, first let's create a list where we'll pass with the type of map entry that will allow us to store our key value pairs within a list. We need a list to be able to transfer the first of all, we will transfer the elements from our linked hash map to a list, and since we cannot sort the elements in the linked hash map, we should create a list that will allow us to use the collections.sort method that comes with comparator comparing, that will allow us to sort the elements depending either on the value or key. Or in this case, we want to sort the elements by the values. So let's continue with the creation of the list. So we can call this entry list and use the keyword new to call the constructor array list to create an array list. And here we can use the method of map, which is called entry set, that will allow us to get all the key value pairs from our linked hash map and put it within the parentheses that will allow us to directly assign the elements from our linked hash map to our newly created list with the name of entry list. And then what we'll do is that we can use the method collections.sort, pass our entry list, and use comparator. So comparator dot comparing, method comparing, and here we use map.entry map.entry double colon and then get value. So what this will do is that it will sort the elements by the value and put them to our entry list. Then we can use the method clear. So map.clear to delete all the elements from our map and transfer from the list to our map. So again, we can use a for loop. Again, use map.entry string with the types string and call it entry. Use colon, and here we should specify the source of our element, so it will be entry list. So for each entry in entry list, we can say so we want to put entry to our map, so we use the method put. Map is our linked hash map, and then we want to put the key and value from our list. So what we do here, we use entry dot get key and entry dot get value. Alright, so this will allow us to transfer the elements from our list to our map that we just cleared, and the elements will be in sorted order. So let's go and check that. So first we can print the message before sorting, and I will copy all of this. And this is after sorting. In between, I will call the method sort that we just specified over here and pass our linked hash map with the name history. So let's go and run this. As we can see, so this is before sorting, the same order, and after sorting you can see A, B, C, D, E, F, G, H, I, J, K, L, M, N, N, O, P, Q, R, S, T, U, V, W, H, Y, and X, Y, Z. So this the values are sorted in ascending order, I mean alphabetically. So it's correct. Now let's move to the next task, which asks us to implement a list recently used cache based on linked hash map. So let me get rid of this. And this. And let me remove all of this as well. So we'll call it cache. And the key will be of type integer. So let's add some elements to our linked hash map using the method put. So cache put 1, let's say 1, 2, actually, to make our program more precise, let's create a class called LRU class. So list recently used cache with return types key value. So KV stands for key value, and let's make it extend. So inherit the properties of linked hash map. Linked hash map with types key value as well. And here we'll create a field capacity, and it will be immutable. So we can use final integer capacity. Then we'll create a constructor LRU cache with parameter capacity. So we'll use this capacity equal to capacity. Alright, and also one more thing. Also, we forgot to use a super method that will allow us to refer to the fields and methods of the parent class, which is linked hash map. So here first we pass the capacity. So the capacity, then we can see that we're asked to specify the load factor. So let's put it 0.75. So basically load factor is a threshold when our LRU cache will understand that it's time to resize. Resize means double in size. So when our bucket will be filled 75% or above, it will resize. And here we specify either true or false for the access order. So we say true because it will allow us to enable the LRU behavior, the least recently used cache behavior. Alright, so and also we should override one more method, which is public. Let's keep it protected actually. Protected boolean remove eldest entry with parameters map dot entry key value. And so what this method will do is that it will remove the eldest element when the size exceeds capacity. So when the cache exceeds capacity. Alright. Also here, should give it a name. Let's call it eldest. And this is override. So by default it's false, but we redefined it, so let me put an override here. And so now what we can do is that we can create an instance of our LRU cache. So we can call LRU cache with capacity 3. So Now let's print out our cache. And let's access the first element. So cache dot get first. So what this will do is that it will make one recently accessed, and then when we try to put a new element, so let's say 4, and return our cache, print out our cache. So we can see that it will remove the second element, because so before we can see it 1 2 3, then 3 1 4, because the elements are not in sorted order, the order of the elements, the order of addition is not preserved. So why did we delete the second cache? Because when we create the elements 1 2 3, 1 was least recently accessed. 1 was the least recently used, right? Then we accessed 1, and 2 became least recently used cache. And when we put 4, so 2 is still least recently used cache, so it was removed from our cache, from our linked hash map. So yes, that is it. Now let's move to our tree map. We're asked to create a tree map and add 5 keys, names and values, scores, and I'll put the sorted data. So tree map, let me get rid of this. So tree map is basically a collection where we can say a map implementation based on a tree, so where the elements, to be more precise, the keys are, the elements are sorted according to keys. So let's create a tree map. So names will be string, our keys will be string, and values will be integer. So string and integer, and we'll call it let's say tree, and create a new tree map. Oops. A new tree map. And to be able to add the elements to our tree map, we can again use the method put. So tree dot put, and let's start. So the name's right, John with the score 95. Let's give it 85 and call it Alex. And then let's create two more. Say 80 Sam and let's say Walter. Some random names. 90. Alright, so now if we try to print out the elements of our tree, if we try to print the elements of our tree, what will happen? Like I said before, elements in the trees are sorted by the keys. So in this case, keys are our names. It means that since it's a string, it will be sorted alphabetically, so in ascending order. So it will start from Alex, then it will go to A, B, C, D, E, F, G, H, I, J. So it will start from Alex, then John, then Sam, then Walter, according to alphabet. So you can see Alex, John, Sam, Walter. And let's add one more. Let's say what? Let's say Bob. So now Bob will be second. So Bob is second because A, B. Alphabetically B comes after A. Alright. Now let's find the minimum and maximum key in a tree map. So how can we do this? So let me create another tree and let's rename it to map to be more precise. So this is basically a map implementation based on tree. And then let's make our key integer and value string. So I will quickly add some elements. Let's say 10. And I will quickly put some random values. Let's get 100 and make it 30 or even 75, let's say. Okay. So as you can see, they're totally in random. They were added in random order, even though if we try to print out this, it will be in sorted order. So 10, 75, 80, 90, 100. Alright, so what we can do to access the minimum and maximum value is that since the keys in tree map are in sorted order, we should access the first and last element. To be more precise, the first and last key. So what we can do is we can use a method. So first let's say list key. We can use a method called first key and last key. So in this case, list key will be the first key, and then actually let me say minimum min key and max key. To access the max key, we take the last key of our tree map. So we should get 10 and 100. Let's see. So this is it. The minimum key is 10 and the maximum key is 100. So correct. Now let's implement a tree map that stores employees and their IDs with the ability to look up the nearest higher ID. So let's create employees. So let's say employee 1. And let's call it Smith. Employee 5. So the numbers will be the IDs of the employees, and I will just write some random names. Say Artyom with the ID 3. Here we can put ID 2 with the name Jessica. And say Josh. Too many J's. Let's call it Ben. Okay. With the ID 4. So what we were asked. So we have employees and their IDs. And the ability to look up the nearest higher ID. So it means that we can create a variable with the type integer. Let's call it search ID. And let's say 4. So actually we can keep it as a normal primitive data type int, because we're not using any methods of the map here. So but in this case, if we want to store higher ID, we will use the method map dot higher key and pass our search ID. Then we need a type of integer with capital I, because it's a wrapper type. So wrapper type is basically a higher level of integer which allows us to also store the null values. So in case we get a null value, we wouldn't get an error. Now let's write some conditional statements. So if our higher ID does not equal to null, then we'll print out we will print out the higher ID. And let's get some message. say nearest higher ID. And let's also specify the name of the employee. Employee. We can use map.getValue. Get and pass the key. So higher ID. And else we'll print out the message. Say none. Alright, so in this case our search ID is 4, so we should get 5. We should get Kelly. Let's go and run this. So the nearest higher ID is 5 and employee Kelly. So, but if we were to say 5, then there is none. There is none. No such employee with higher ID. Let's try one more. Say 0. And we get nearest higher ID 1, and this is Smith. Alright, now let's move to the next one. Write a method that merges 2 tree maps, removing duplicates. Let me get rid of this. So let's create a second tree map. Let me just copy this. I'll call it map 2. And also let me copy these elements. And I will say map 2, map 2, map 2. But I will change Smith to a different name, so this is not a duplicate. Say Tom, and I will change Kelly. Say James. So these are duplicates. And they should be deleted when we merge these 2 trees into a 1. I guess in this tasks they ask us to keys to be unique and not the values, so let me go back and let me remove this. Create some unique values. So map to put ID 6. Let's call it James. One more. ID 7, and let's call it Paul. So we have duplicates here, 1 and 5. Right. And let's create a method. Public static And let's pass the key value identities, and the return type will be tree map. So tree map with key value, with the return type key value. And the name of our method will be merge tree maps, and in parameters we'll pass map 1 and map 2. So tree map with a return types key value, map 1, and the same tree map with the return types key value, and name map 2. So here we will create a new tree map with types key value, and we'll call it a merged tree. It's a merged map, and we'll create a new tree map, pass our first map to it. So the values of the first map will be stored in our newly created merged map. And now what we can do is that we can use the method put all. So merged map dot put all, and put all the elements from map 2. Alright. So what this will do is that it will add the non-duplicate elements to the merged map. Alright, and then in the end we will return our merged map. So let's create a new tree map with the types integer and string, and we'll call it merged map. And here we can call the methods merge tree maps, pass our map and map 2. And at the end of the day we can print out a tree map. So merged tree maps. Let's go and run this. So we can see that we have only unique elements in our map. So we had Smith and Kelly in both of the maps, but they were not added, and only James and Paul were added to the merged map thanks to the method put all. Alright, so the last task is to implement a caching mechanism where keys are automatically removed if they become stale. Alright, let me get rid of this. And this. So let me get rid of this as well. And let's call our tree map cache. And let our keys be the string of type string, and the values will be the expiry time, so integer. Now we'll we'll put some values to our tree map. Let's create two users. So cache dot put, so user 1, and to get the current time in milliseconds, we can use the system dot current time milliseconds. But to do this, I guess we need to import some libraries. Let's actually create a static class to be able to store more precise information about our cache. So let's create static class cache entry, and here we'll have fields like string, user, or we can say string name, right, and then we'll make it private. Or we can say string value as well. Why do we need to make it private? And the timestamp of type long. And now let's create a constructor. So public cache entry, that will accept the string value and timestamp. So we can use the keyword this to refer to the current value, and this to current timestamp. So now if we want to make a more precise addition of elements, we can specify here cache entry and start entering the name and timestamp. So new cache entry, and the name, let's say John, and timestamp, let's say 2000. So these are in milliseconds. Right, and also let's create our own expiry time. Let's go long expiry millisecond, let's say milliseconds. Let's make it 3000. Actually, the timestamp should not be 2000. I made a mistake here. We'll get the current time from the system using system dot current time milliseconds. And let's create one more user. So this will be user 2. with the name, let's say Tom. Alright, so now let's also create a method, a static method cleanup, where we will pass our our map, so tree map, with the return types string and cache entry. So cache entry, and let's say cache and our expiry time, long expiry time. And here we'll create another variable, call it current time, and we'll assign it to a current time using system current milliseconds. And then we will use cache dot remove if also we forgot to write the entry set, so entry set remove if. So cache entry set will return the key value pairs, and remove if will allow us to remove the element, a specific element. We can specify it as entry, and then use this arrow and here comes the condition. So if the current time minus the expiry time is greater than the cache dot get value, so cache dot entry set dot get value, actually not, it should be entry, it should be minus entry dot get value, so dot timestamp is greater than the expiry time. So in this case we will remove that element from our map. Alright, so now let's go and print. So let's go and print our cache before and after. So after clean up our map, so cache comma the expiry time, which is expiry milliseconds, and then we'll print out cache again. In between that, let's make our thread sleep. Sleep for 4 seconds, let's say 4000 milliseconds. And in order to use that, we should throw an exception here. Throws interrupted exception. Sorry, it should be in the main method. Put it in the wrong place. Throws interrupted exception. And now we can run and see the result. Let's actually implement a print method instead of this. So let's say cache dot for each to traverse all the elements of our map. For each key value, so key value, and use this arrow and print out the key plus the value. Alright, and let me copy this, put it here after thread slip. So let's go and run this. A small change here. Should change it to entry to be able to access the value of the entry, tree.value, like this. Same here, entry.value. Let's try to run this one more time. So first we have user1, user2, and still it prints the value, so there must be a mistake. The one mistake is here that the cleanup should occur after the thread slip, so after the time expires, the cleanup occurs and we print out the entities. So let's go and run this one more time. So we can see user1, user2, and then should be null. So there's nothing. Instead of this, we could also print out. We could use the method isEmpty. So cache dot isEmpty to see. Should be true. So it's true means our map was successfully cleaned up. Now let's move to the next task. Priority queues. Create a priority queue and add 5 numbers. Print them in order of removal. So let's get rid of this and this.
So priority queue is basically a queue implementation where the tasks are executed not in the order they were added to the queue, but in the order of priority. So in order to create a priority queue, we use priority queue notation and then we'll pass integer for the current example, and I'll call it PQ, and create a new priority queue using the keyword new, and then we can add the elements to our priority priority queue using the add method. So let's add 5 numbers. We'll say 66, 13, 19, 30, and 47. So to retrieve the elements from priority queue, we can use the method poll, which will take the least significant number, so the smallest number. So we can use a while loop to get that. While pq dot is empty, and we want to reverse this, so is not empty. We want to print out pq dot poll. So poll so this will print out all the elements starting from the least significant number. So it should start from 13 and all the way up to 66. So now let's move to the next task. It asks to implement a task with queue, a task queue with priorities, add several tasks and retrieve them by priority. So let's remove this. What we can do here is we can create a new class and call it task. Task and implement an interface comparable and pass in our task as a parameter. And then we will declare 2 fields using private keyword, private string task and private private integer priority. So we can also make it, rename it to name. So it's basically name of our task. Now let me quickly generate the constructor and getters. So generate constructor and generate getter. Getter for both fields. And now we should override the method compare to, because Java, the priority queue collection internally uses this method, compared to when adding the elements to the queue and when removing the elements from the queue. So when adding to the heap, it uses the method compare to determine the position of the element in the queue. So by default, it's a min heap, which means that the elements will be added. It means that the lowest elements are in the head and elements are retrieved in ascending order by default. It's a min heap. But what we want to do is that we want to store the elements in the reversed order, or meaning from highest to lowest. So in order to do this, we should overwrite this method. Like I said, Java uses this method internally for the priority queues, and if we don't override it, the queue will not understand in which order we want to proceed the tasks. So public void compare to so in parameters we have task, let's call it other, it has a return type of integer, so we'll say int, and here we'll write the wrapper integer dot method compare, and here we compare other task by priority, so other dot priority, comma, this priority. And one more method that we should override is a method to string. So override public string to string and it will return this message, task plus the name, so we have a field name, right, and also we will return the priority. So priority plus priority let's close. And that's it. Now we can redefine our priority queue and use a type task to be able to store more complex data in our priority queue. So pq.add. Then we can say new task, and here, so we start from the name. Let's say fix bugs. It's the name of our task, and the priority will be 2, let's say. Let me add more tasks quickly. Alright, I have copy pasted some tasks. So now what we can do is that we can see the results. So as we change the logic behind the default priority queue, now the elements will be stored by the priority. So meaning it will store elements starting with the highest priority, so that we can see that running the program. So it will start from 5 and then go up to the least significant priority. So this is how we can implement the priority queue. Now let's move to the next task. So we're asked to use priority queue to sort objects by priority. It's basically the same task, but for the sake of practice I will show another method. So let me remove all of this and let's stick to integer. I will remove these as well. So let me quickly add some elements, some numbers to our queue. Some random numbers. So like I said before, usually these numbers are stored from smallest to highest by default, but we can change that behavior using the method reverse order. So that method is contained in the interface collections. So in order to implement it, we write it within the parentheses of the priority queue. So collections dot reverse order. So now what will happen is that it will reverse the order. So it will start from 68 and then go down to the smallest number. But if I remove this, you can see that the order is different now. It starts from 5. So now let's go to the next task. Implement a priority queue that allows changing the priority of an already added element. So basically it is the same as our previous task, this task, but we need to add a setter. Let's go on and implement a setter. So public void set priority integer new priority. So priority is equal to new priority. Alright. So setter alone is not enough to make our priority queue to be able to change the priority of the tasks. In order to do that, we should create another class and have our priority queue and a hash map to track the elements for fast lookup. So why do we need a hash map in this case? Because priority queues, we cannot actually we can set the priority, like we implemented a setter here. We can set the priority, but the order of that task will remain the same, and it will not reorder itself. So to do this, we can set the priority. Then remove it from the queue. Find from the hash map. So in the hash map, we will have a predefined list of our tasks. So we'll copy all the tasks to the hash map. And in case we want to change the priority, we just remove it from the priority queue. We find it from the hash map and then reinsert to our priority queue. So let's go and create a new class where we will have our hash map and priority queue. So we will call this task priority queue. And we'll have our fields priority queue with the type task, of course. So remember that task contains the name and priority, and here we create a hash map with the types string and task. And also let's not forget to give the names. So we'll call it a map. Just a map. This one I will call PQ. Alright. So let's create constructor. So the name of the constructor matches with the name of the class. So task priority queue with parameters no parameters, and here we initialize our collection. So PQ new priority queue. So in this case, what we want to use the comparator, and then the method comparing int, since we'll be comparing the priority, and then we want to compare the priority, so we can use this notation, task get priority. Alright, now let's initialize our map. So new hash map. Alright. Let's create a method. Add task, so public void add task. So to add task we need a name of the task, and priority, so integer priority. And here we create an instance of class task, so task new task, the name and priority. And then remember we added to queue and the map, so pq.add task and map.put the name and task. Another method that we want to add is the method changes the priority, so void change priority, and that has a parameter integer new priority, and also the name of the task, so string name. So within the method we will have a conditional operator if, so if our map contains the key name, then we will get the priority of that key, so task map.get name, then what we will do is that we will remove that task from our queue, so pq using the method remove, pq remove task, then in the map we will set the priority, not in the map but in the task to be more precise, so task.set priority, and pass in the new priority, and then we add it back to the queue, so pq dot add task. Now let's try to see what we get here. So now it's not a priority queue but a task priority queue. So task priority queue. And it's not a collection anymore, it's a class. So we remove task priority queue. Alright. Now let me quickly change. Since we redefined the method, we should put an add task here. And get rid of this as well, since we do not create an instance of class task anymore. So rename Alright, and now since we're working with the with the type task and not with some stream of integer, we should also create a method poll, so public with the type task. So task poll poll task. That will allow us to poll the task from our queue. So we create an instance of class task. So task pq dot poll. And then we have a conditional statement if task is not null. So if task does not equal to null, we will remove the task from we will remove the task from the priority queue. pq dot remove task dot get name and return task. And this actually should be map, not pq. So we're removing the element from the map. And let's create a method isEmpty so that we will be able to use that in our class. So isEmpty and that returns pq dot isEmpty. So now we can try to change the priority. So pq dot change priority, So let's change the priority of writing the docs. So I will paste it here. And the new priority will be, let's say, 4. And then, so remember we redefined the poll. It's a poll task right now. And we can see the results. So as you can see, priority with the weight 2, priority with the weight 3 and 4. Let's actually change another one. So that we could see it better. Let's change this task, the priority of this task, to 4. And let me print this before and after. Let's go and run this. So actually what happened here is that the method poll task, it removes the element, so we cannot print it twice. Let's stick to our single while loop. So as we can see, the task is on its place. Everything works correctly. The next task is to write a task scheduling system where tasks are executed by priority, and in case of equal priority, in the order of addition. So let's see. Let me get rid of this. Actually, let's keep it. Let's keep it. Create an array DQ, add 5 elements and print them. So array DQ is a collection that allows us to store a double-ended queue. So the difference between queue and double-ended queue is that in double-ended queue we can add and remove elements from both ends, and DQ is basically a queue implementation. So to implement a DQ we can use the class arrayDQ. And let's say the type is integer, so let's call it DQ, new arrayDQ. So to add elements to arrayDQ, we can use method add. So let's add 1, 2, 3, 4, and 5. And to print our DQ, we can use the system out print line. function. Let's go and print this. So this is the result. Alright. Now use array_dequeue as a stack and add elements and pop them in reverse order. So to use our array_dequeue as a stack, let's actually make it look like a stack. So let's rename it stack. Let's change the type of our stack to a string. So to add elements to our stack, we can use the methods push and pop. So stack dot push. And let's add some fruits. Apple. Orange. Banana. Grapefruit. Pear. So to get the elements, we can use the pop function. So stack is a data structure that operates on the principle last in, first out. So we should get pear, grapefruit, banana, orange, and so in the reverse order. Let's use a while loop. So while our stack is not empty, we'll pop each element from our stack. So print pop. Alright, let's go and run this. So as we can see, the last element was pear, then grapefruit, then banana, orange, and apple. So correct. Now use array_dequeue as a queue and add elements to the beginning and end, pop from both ends. Alright. So let's rename the name of our array_dequeue to dequeue. And let's rename the stack to dequeue. Alright. Now instead of push, we can use the methods add first and add last. So let me just remove this. Okay, so add first, let's add this to the end, add last, add first, let's add this to last, add last. So let's see what we get. So we should have grapefruit, orange, apple, banana, pear. Let's see. Actually, let me remove this. orange, apple, banana. Banana was last. Then the last one was pear, so correct. Now to remove the elements from both ends, we can use remove first and remove last. So let me print that out. So let's say dq dot remove first, and then let's remove one element from last. So what we should get in this case, actually let's keep the q. So we should get, let me put this in the beginning and copy it, put it in the end as well. So let's see. So the first element is grapefruit and last one is pear. So here we use the method remove first, we got the grapefruit, and then remove last, we got pear, and in the end we have this list. So everything works correctly.
Okay, so let's create an undo and redo system. So first let me remove this. So we want to have a system that remembers our actions. So if we undo some action, it should be also written in our collection. So let's create a new class, undo redo system. And so let's declare two fields. So private. So let's declare a stack undo and stack redo of type array_dq. So array dq of type string. So undo stack and redo stack. Alright, now let's create a constructor. I will generate it. So this is wrong. This is not what we want. We want to initialize the stack. So undo stack is equal to new array_dq. The same for redo stack. Redo stack. Alright. So now let's create a method, public, a method that will allow us to perform the action. So void perform action. So the action is string action. So we will take our action and push it to undo stack. So undo stack, use the method push and action. Then we can print out some message. Let's say action plus done. Alright, now we want to be able to undo the action. So let's write a method undo. So again we have action. So first what we do is we check, so if we check if our undo stack is not empty. So undo stack dot is empty. So if this condition is true, if this condition is met, then we can create a variable last action. And then we can pop the last action from our undo stack. So pop, and also we want to be able to redo this action, so we write redo stack dot push last action. Alright, and we can also print some message like last action plus undid successfully. Success, I guess, like this, successfully. Alright, and also we'll have an else statement. So else, it means our stack is already empty, and we'll say nothing to undo, like this. Now let's create a method redo. So redo, actually we don't need this string action, we don't need to pass that because we already have the track of our action. And to redo the action, so again we'll have a condition here. So if the redo stack is not empty, we'll declare a variable last and done action. So last and done, and we'll pop the last action from the redo stack. So redo stack dot pop. And then we also need to push that stack to the undo stack. So undo stack dot push last undone, and we can print out some message last undone successfully. Successfully. Okay. And else we can print some message nothing to redo. Alright, so now let's go to the main method, to the entry of our program, and create an instance of the class undo redo system. So let's call it editor. Let's copy constructor, create undo redo system. So let's add some action. Editor dot add, oops, perform action. So editor dot perform action, and let's say some action, some action one. Or let's be creative and say what? I really have a problem with creativity. Edited picture or something. Okay, let's say action one. Okay, action one, action one, action two, action three, action four. Alright, so we perform some actions. Now let's redo. So, I mean undo. Undo. And then again undo. And redo. So, action. And let's see what we get. So action 1 done, action 2 done, action 3, action 4. Action 4 undid successfully, action 3 undid successfully. Yeah, this looks like I have a spelling mistake, grammatical mistake. So in this case it should be redid successfully, undid successfully. Alright, let's go and run this again. Undid, action 3, action 4, action 4, action 3. And you can see action 4 undid, action 3 undid, and action 3 redid successfully. We can also try to print the result in the end. Editor. Let's see what we have. Uh-oh. So we should use a for loop. Let's actually implement a method. Public void print actions. So, what was the name? Undo stack. Actually, let's not overcomplicate things since we were not asked to create a print method. And let's move to the next task. Implement a method that checks if a string is symmetric. So we should check if a string is a palindrome or not using the array_deque. So let me remove all of this. And let's write a method. Public static method that has a return type boolean is palindrome. that accepts, that has a parameter string. Let's call it str, and the body of our method is as follows. Let's create an array queue, array dequeue, with the type character. Let's call it dequeue, new array dequeue, and so we want to separate all the characters from our string and put it to array dequeue to be able to use the methods remove first and remove last, and put it in a while loop to check if a given word is a palindrome. So now we write a for loop. So for character C, for each character C in a string, so we should convert, now it's a string, so we need to convert it to a single character. So we can use the method to character array, and then we want to put each character to our dequeue, so we can use dequeue dot add last. So it's important to add it to last, because if we just use add, then the order of our characters can be messed, because it's a queue and it sorts, I mean, it's a we could use add as well, but in this case add last, it improves the readability, and you can understand that we're treating this dequeue as a queue, so basically no difference. And after we added all the characters to our dequeue, now we should check, so we can use the methods remove first and remove last. So let's put it within a while loop and say while the size of our dequeue is greater than 1, so dequeue size is greater than 1, we'll have a condition, if condition, so if dequeue dot remove first or remove last does not equal to dequeue dot remove first, then will automatically return false, because that's not a palindrome. And if we exit that loop successfully, then it means it's a palindrome and we will return it true. If not, it will return false and break out of the loop, and we'll get our answer. So let's say we have some string, let's say word race car. So as you can see, this is a palindrome. And let me add another word. Actually, we can use it directly. We can put it directly to our method. We don't have to declare a variable and initialize a variable. So let's call our method is palindrome, and then pass our argument, and we want to print out this. So add one more. Let's say something like hello. So this is a palindrome, the second one is not a palindrome, so let's go and see, it should be true and false. As you can see, so R A C C, and E is ignored because it's just a single letter. So this is true. And hello is not a palindrome because the first and last letter, they're not matching with each other. So now let's go to the next step. So here we're going to design a Java program using collection based on the tasks. The system has a list of unique user IDs. It's necessary to quickly check whether a user with given ID is present. Alright, so let me remove all of this.